Hi, 6th grade math students. This is Mrs. Jones this time. We are starting a new unit which is called Equivalent Expressions. This unit kind of picks up right where we left off before spring break, which I know feels like it was forever ago, but we were working on algebraic expressions then, and we're going to continue doing some more work with algebraic expressions in this unit. So our first topic is over what is called combining like terms. And we're going to start with some vocab, and some of this will be review. So if you recall, an algebraic expression is just a mathematical statement that involves numbers, operations, and a variable. Okay. Terms, this is a new word. Terms are the parts of an expression that are separated by addition or subtraction signs, and I'll show you what I mean by that in a few slides. And then to go along with terms, we have what are called like terms, and these are terms that have the exact same variable part. And again, I'll show you an example of these in a little bit. These next three words should be all review for you. Remember, a variable is a letter that represents an unknown number. So when we're looking for a variable in an expression, we're just looking for the letters. Then we have coefficient. Remember, means that prefix co means with, like coworker. So a coefficient is the number that is with the variable. And then our last one is constant. If you remember, we looked at that picture of the teddy bear that had been lost. So it was alone, and we said it's constantly alone. So constant is the number without the variable. Okay, so if we look at this algebraic expression, we have 3x plus 7 plus x plus 2. All of those addition signs separate the terms. So this expression has 4 terms. 3x is a term, 7, x, and 2. So 4 different terms. Okay. Remember, for coefficients, 3 would be the coefficient of this x, and then this x also has a coefficient, it's just invisible. This x has a coefficient of 1. And then 7 and 2 are constants. Now when we're talking about like terms, we're saying which terms kind of look alike, or which terms have the same variable to them. So 3x and x would be like terms because they both have an x. And 7 and 2 are like terms because they are both constants, or because they both do not have a variable. Okay, here's another example. 5y plus 3 minus 2y. In this expression, 5y and this negative 2y, I'll explain that more, but 5y and negative 2y are like terms because they have the same variable. They both have y's. Okay? 3 is a constant, and it's the only constant in this expression, so it does not have a like term. Okay, so we are going to practice identifying like terms, and I'm going to show you what it means to combine them. So if we look at this expression, 3x plus 4 plus 4x, I'm going to start by looking for my variables. And I notice that I have a variable here with the 3x, and I have a variable here with the 4x. Okay? Because these are like terms, I can combine them. And we just combine them by adding the coefficients. So all I'm doing is adding 3 plus 4, which is 7. And since it's 3x plus 4x, this is actually going to be 7x. Then 4 is a constant, so we cannot add it to the x's. But there's nothing else to add it to, so we just put it on the end of the expression, 7x plus 4. And that should look more like the algebraic expressions that you're used to from our last unit. Okay, so 7x plus 4 would be our final simplified answer for this expression. What I mean by simplified is that I can't add these together because they're different. This one has an x, this one doesn't have an x, so they cannot be put together. Let's look at another one. 5x plus 3 plus 2x plus 4. Again, I'm going to start by picking out my terms that have variables. So I see a 5x, and that looks like or matches this 2x that's positive back here. So again, I'm just going to combine coefficients. 5 plus 2 is 7, and then it has an x with it, so 5x plus 2x is 7x. Then this time I notice that I have this constant of positive 3, but I also have this constant of positive 4, and I can add those just like adding regular numbers. 3 plus 4 is 7, so I'm going to add a plus 7. Okay, so this expression simplifies down to 7x plus 7, and that's my final answer. One more on this slide. 6x plus 2 plus negative 3x plus x. All right, there's lots of x's in this one. So start at the beginning. 6x. This one is a negative 3x. And then this one is a positive x. All of these that I circled are like terms because they all have x's. All right, so I need to think about how to add things again when there's some negatives. Remember that negatives, just like subtraction, they mean the same thing. Or you can use our pictures that we used at the beginning of the year when we were working with integers. So if I have 6 x's, that's like having positive 6. So I'm going to make 6 positive signs. Then I have 3 negatives, so I'm going to make 3 negative signs. And then I have another positive x. I'm going to put that over here with the other positives. Right? Remember, when we have opposites, like a positive and a negative, they combine to equal 0. So this positive and negative cancel out, this positive and negative cancel out, and this positive and negative cancel out, and that leaves me with 4 positive numbers. So that means 4 and then x, okay? So 6 and negative 3, remember that's just like 6 minus 3, that's 3, plus the invisible 1 here makes this 4, or use the picture if that helps you. And then I also notice that I have a constant here, but there's nothing that is like it. There's no other constants, so I'm going to include the plus 2 on the end. Okay, it is typical that we list the variable piece of the expression first. That's why I have the x at the beginning of the expression and the constant at the end in all of these. But if you had these switched around, that's okay. This would be the same thing as 4 plus 7x, or 7 plus 7x, or 2 plus 4x. You can have those flipped around and it still means the same thing. It's just more typical and kind of standard form to write it with the variable part first. All right, let's look at some more slides, and we're going to use some that have more negatives in it, like that last one we just did. So, negative 2x plus 4 plus 5x plus 1. I'm going to again start with my variables. So I see negative 2x and positive 5x, okay? The sign in front of it, the subtraction or addition sign, tells us if it's positive or negative. So it's because there is a plus sign in front of the 5, that's how I know this is positive. Okay, I'm going to use my pictures again. So if I have negative 2, I have 2 negatives, and positive 5, I have 5 positives. 1, 2, 3, 4, and 5. Then remember, opposites combine to equal 0, so this one cancels and this pair cancels, and that leaves me with 3 positive x's. So this is going to be 3x, okay? Or you can think of it as positive 5 minus 2, which is 3. And then I also notice that I have some constants here, so I have positive 4 and positive 1. So positive 4 and positive 1, I can just add those like regular numbers. That makes 5, and it's positive 5, so I'm going to write this as 3x plus 5, and that is my final simplified answer here. Okay. In our next one, 3y minus 6 plus 2 minus y. I'm going to start again by picking out my variables. Right? Just because it's a different letter doesn't mean we need to change anything. Right? 3y matches with this negative y, and remember, this is like a negative 1. That 1 is just invisible. So on this one, if I have 3 positive y's and 1 negative y, my opposites combine to equal 0, and I have 2 positive y's left, or you can just think of it as 3 minus 1, which is 2y. And then for my constants this time, I have negative 6 and positive 2. Right? Again, you can use your picture here, 6 negatives and 2 positives. Right? This pair combines to equal 0, this pair combines to equal 0, and I'm left with 4 negatives this time, so I'm going to write minus 4. So my simplified expression here is 2y minus 4. Let's look at negative 4c plus 3 plus 4c minus 5. And this one, again, start with my variables. I have negative 4c and positive 4c. Think about that one. If I have 4 negatives and 4 positives, what's going to happen? Well, every single one of those has an opposite, so they all cancel out. That means I have no c's left, so I'm not going to write anything for that. Then I look at my constants, and I have positive 3 and negative 5 for constants. So 3 positives and 5 negatives means that when I cancel out my pairs of opposites, I'm left with negative 2. So my final expression for this one is just going to be negative 2. All of the c's, all of the variables canceled out over here. Right? One more example before I have you try some. Right? This one, 3x plus 6 minus 4. Well, I notice that there's a 3x, but it doesn't match anything because there's no other x's. So that one's just going to stay 3x. And for my constants, I have positive 6 and I have negative 4. Right, we can draw out a picture of 6 positives and 4 negatives, or we can just think about it as 6 minus 4. And we know that that leaves us with 2. Okay, so we're going to have a positive 2. All right, so that is our examples on combining like terms. So what to do next, go back and rewatch this video as much as you need to. You have 7 examples that I worked through, so follow those examples and make sure you understand how I'm getting the final expression that I am. Then please go through and try the independent practice that's posted on Classroom. It's just 10 questions for you to try on whatever paper that you have. It's not turned in. Just use it to make sure that you know what you're doing. Check the answers using the answer key. That'll tell you if you understand and you're ready for the check-in, or if you should go back and either rewatch the video or reach out to your teacher. And then last, do that check-in on Google Classroom. Your teacher will see it and give you some feedback, but it is not going to be a grade. Right? If you have any questions at all, please send me or send Mrs. Gall an email. Have a great rest of your day.